All right. Hi, everyone. So we're going to jump in and look at a data science workflow starting from importing our data, building models, explaining the models, productionalizing them, and then using and building AI apps. I'm going to start with a brief overview of the H2O AI Cloud. Reed's told you its business value and what we can do with it, but let me just walk you through the UI. So we land in the AI Cloud as our end-to-end platform for machine learning. At the top, I have some of the key functionalities of what I'm going to be doing today. I'm going to import data. I'm going to build machine learning models. There was a session earlier this week, a deep dive on hydrogen torch and deep learning. We're not going to do deep learning today, but we can, and that's totally available at H2O. We'll then deploy a model. And everything we're going to do today is going to be from the UI. It demos quite nicely, but some of you might be data scientists. You love to write your code in Python or R, and you can do that directly from the AI Cloud with notebooks. So from our Jupyter Notebook app, you have access to instances of Jupyter Labs directly from the cloud. And in this environment, it comes with all the APIs pre-configured and also example notebooks that will go through everything we're looking at today. So it allows you to start writing your own scripts and notebooks for your machine learning process. So this is available, but we'll stick to the UI today. So I'm going to go back. In addition to some of our core capabilities that we'll do a deep dive, we have some AI apps that help us with the end-to-end machine learning workflow, including finding new insights in our data, looking at auto documentation, and then also validating if a model is ready for production or not. In the center, I have things that are helpful to me as an end user. So if you have either the AI Cloud platform as a product or you're in our free trial, you will see different things here. But I can see here instances of AI apps that I'm running. I can see my favorite apps that I've pinned that I want to use every day and have easy access to. And then I can see as an app developer things that I've imported into the cloud so I can better manage those. And this environment is configurable. So here at H2O, we have some tools at the bottom for H2O that help us do our own jobs. We can also see what's new in our app store. So at this point, we'll start by walking through a use case and we'll upload some data. So I'm going to go to Drive, where I have my data connectors and all the data that I want to use in the AI Cloud. Like Reed mentioned, depending on our use case, there are different types of things we might do to solve our problems. We might have really big data in which we want to use H2O for distributed machine learning or open source models. We might want to use Driverless AI for automated machine learning, feature engineering, and so forth, creating pipelines. We might want to use H2O hydrogen torch for no-code deep learning. Regardless, we can upload our data in one place and use the same data set in different AI engines and different apps. And that's what we're going to do here in Drive. So you can see I have some data I've uploaded ahead of time. I can configure connectors. So if I want to connect to any of my common data stores, such as Snowflake or Amazon S3, I can add in my credentials. These are securely saved. I can add multiple credentials, and then I can easily bring my data in. I can import data. We do have example data sets that come with the system. So if you want to kick tires, but you don't have a specific data set or you're not ready to upload your own private data yet, there's data there for you. Or I can go through and import my data. So I imported data ahead of time. We won't do it today, but we can see the idea of it here. And it's now in my cloud platform for me to be able to use. All right. Back in the homepage, I'm going to actually go into Driverless AI and we're going to start building models. Now, we're going to do a one-click directly into a Driverless AI instance, but some of my data scientists might be familiar with the idea of scaling a machine or your environment for the work you're doing. So if for some reason I am doing like a really big image problem and I know that I need like 5 GPUs to get my work done, I would actually go, I have too many tabs open. I'd actually go into the My AI Engines area of the cloud where I can completely configure and scale these to my needs. I can add more RAM, I can do less RAM, so it costs me less money, add or remove GPUs and so forth. So we do have full control as end users of this and our admins have control over what we have access to. But today we're going to just jump right into the environment. We're not too concerned with that resource management. Here you can see data sets I've uploaded ahead of time. If I go here, I have my access to Drive where I can see all of the data sets. We'll just go to the root. I can see all of my data sets that we just saw in Drive, and I can bring them into this specific Driverless AI machine if I wanted to. I imported those ahead of time. So let's go ahead and look at our data. When we do data details, we can see the data that we're going to be working with today. We did have 5 of 15 people that did our poll said they're working on customer churn. So maybe you've seen this Kaggle data set before on customer churn. This is specifically from a telco provider. So we have information about how a user interacts with their cell phone plan. Do they have an international plan or not? Do they have a voicemail plan? Are they being charged more for day or nights or weekends? A lot of our cell phone plans are everything today, but might still be split up. We can also see how many times they've called customer service. And then historically, we know who's churned and who hasn't. So this gives us some information where we historically know what happened, and we're going to build a model where we try to predict who's going to churn next, and potentially more importantly, why are they going to churn next? If I want to visually explore the data a little bit more, I can use the visualize button to run and create some automatic visualizations that will show me interesting things about my data. So every data set is going to have different characteristics that are interesting about it. Here I can see if there are any histograms that are skewed, values I might want to know about. We can see that for the most part, most of our customers have not called customer service a lot. This is a skew that we like. We don't necessarily want this normally distributed, but it's good to understand what's in our data set and that we really aren't seeing anything that's suspicious or that we might want to change. Once I'm comfortable with my data, I've explored it, I might want to go ahead and start building machine learning models. So I'm going to use the predict button. And today we do have labeled data, so we're going to do supervised machine learning, but we do have the ability to build unsupervised models where we're not looking for a specific problem to be solved, like will this customer churn or not, but it's a little more general, like what are some trends in this data? What are the groups of customers that are similar? So we do have unsupervised capabilities in Driverless and throughout our platform, but we're going to focus on our labeled and supervised machine learning today in our demo. So the only thing I really have to do for supervised machine learning is say what it is I'm trying to predict. And what I want to know is someone going to churn or not? I want you to use my historic data and understand who's going to churn and who's not. Based on my data set, you might see it's a little bit small. We usually do machine learning with bigger data, but based on my data, it has set some settings for me automatically. So accuracy, time, and interpretability is a trade-off on the type of model that I'm building for my specific use case. In this case, one of the things that I want to be able to do with this model is I want to use this model to enable my customer service team with information when the customer calls in. So having a really interpretable model where it's very easy to pull out what key features are leading to a prediction is really important to me, because when someone calls in and is mad, I want customer support to know that they are probably likely to churn because they have an international plan, because they've called customer success 4 times because of whatever reason. So for me, interpretability might be even a little more important than accuracy in this specific use case. In other use cases, interpretability might be less important. I won't have to necessarily say why, but I want to get as technical and complicated of a model that's really, really accurate. And so I can tell the machine what is important to me. If we zoom in over on this left-hand side, we can see a plan of what's going to happen when we kick off this automated machine learning job. So Driverless AI is focused on AutoML. It's going to build a bunch of models for us that will compete against each other to find the best one for this specific use case. One of the things I mentioned, 3,000 rows is a little bit small. Driverless is aware of this, and it's going to do things to help me from, making mistakes like overfitting my model. So for anyone that's maybe a little technical on the data science side, you might be familiar with cross-validation. We're going to do 3-fold cross-validation twice, which basically means every model will be lots of little models on different parts of the data so that we are less likely to overfit on our small data set. If we had a lot more rows, then this plan would look a little bit different and would make more sense for that specific data set. For feature engineering, we're going to go through and take our original data and create new features from it. So some of those things might be taking some of our columns and adding them together. So summing columns. If you remember, we have day charges and night charges. Well, it might be really predictive to know total charges, for example. So we'll look at if there's any text columns, we'll do a little text analytics on it. We'll look at grouping and clustering different columns together. And this will all be done for me automatically to see what's predictive in my data. I don't have to guess at what features I need to make. We can also see the types of algorithms that are going to be used. In this case, it's going to try specifically like GBM and XGBoost. Now, maybe you're a data scientist, you like to be pretty hands-on and you have opinions on what algorithms should be used or what your learning rate for light GBM is. For you, we have expert settings. So not every user is going to use or need these, but we do have full control over what's going on in this experiment. So in the model section, I can come in and I can turn different models on or off. Maybe I really want this interpretable and I only want to use a decision tree. Everything else I want to turn on. I want a single decision tree at the end. I'm not going to do that today, but we could. We can go through and we can change the learning rate and the depth of our trees and so forth. And we do not have to, but you do have the control to do this as needed. For some use cases, we have things like features that shouldn't be dropped. We want to use a feature even if it's not predictive in our model. We can control that type of thing in features. And we are talking about a classification problem today, but we have forecasting and NLP and image. So there are expert settings to make sure you make the exact forecasting model you want and so forth. The one last thing I want to mention in expert settings is the idea of custom recipes. So we've talked about algorithms like XGBoost. We talked about feature engineering, like we add columns together or we cluster groups of columns together. But we also have full access to use any custom recipes that you might want to. So if you have found that traditionally when you're solving churn at your customer, this type of feature is predictive, we can write that as a Python module and plug and play into the experiment, and it will be competing against all the other features to see how it does. So this allows every driverless experiment to be very customizable and allows you full control in the models you're building. All right. The last thing, I can pick the score that's best for me. So because I'm doing churn, today I'm going to do F1. This gives me a pretty nice balance in the middle between catching all my people that are churning, but being accurate when I say that they're churning. And so I'm going to click launch and it's going to start doing work for me. At this point, I could leave. It will take probably 5 to 10 minutes to run. We'll go look at another experiment, but I want to talk about some of the things that are happening automatically that as a data scientist, you might normally have to do. So some of it is checking for leakage, and that just happened really fast, popped up on the screen and now it's gone. Essentially, it's going to see if we have any features that are too predictive. So if you imagine for customer churn, I could have included a feature that said, you know, when was the last time this person paid? Well, if they didn't pay for 6 months, then they've already churned, right? They're not paying us anymore. So that would sort of be cheating to use in our model. So we'll do things like that for us. I'm going to jump into an completed experiment. We'll talk really briefly about a couple other features for explainability. There is AutoDoc, which gives you a detailed report on everything that happens in this model. So we can really understand how it works. And we also have the ability to interpret the model and see what's going on in my model. How is it making predictions or not? Due to the time of webinar, we won't do a deep dive on this one, but I just want to show you a couple things that are interesting. For example, I can look at my partial dependency plots and they can tell me how different features are impacting predictions. So I might want to know, how does the number of customer service calls impact whether or not my model thinks someone will churn? And here I can see most people do not call customer service that often, but when they call more than 4 times, their likelihood of churn is much, much, much higher. It doubles, maybe almost triples. So this is a nice business rule for me. 4 calls doesn't happen very often. I'd say less than 200 times in this data set. But if someone has called in 3 times, I should send them to my very best rep, because if they come a 4th time, they're probably going to leave me. So this area of MLI can help us both understand and trust our models, but also come up with some interesting business rules. All right. I'm going to jump now into the project tab. Here are the different types of use cases that I'm working on, both with myself, but with other people at my company. I can share a project for collaboration, and anything in this project, experiments, models, and so forth, my colleagues will be able to see. And once I have a project, I can jump into MLOps and actually look at deployments of those models. So we've built a model, but we want to be able to use it in real time for our call center folks. So I'm going to jump back to my home and click on MLOps. All right, here you can see all the projects that I just saw in Driverless AI, but in a little bit of a different view. And we are specifically talking about customer churn today. In customer churn, I can see the experiments I have. I have 2 different experiments that I've built in this use case. I can register these as models, and I can have versions of models over time for really nice tracking. And then I can actually deploy these models so that they're used. For example, here I have a model and I can see its ID, and let's actually use the model just as a really quick example. Here I have a curl request. It is running as a REST endpoint, so the model is up and it's waiting for me to send it data. I'm going to just use my terminal. I'm going to send it this example row, and it's going to come back and say, this example row where the person never talked on the phone at all, they have a 99.9% chance of not churning. So not a very interesting data point, but we can see we got real-time prediction and the latency is very low. Additionally, in MLOps, we have nice monitoring capabilities. For time, we're going to skip those today, but if there's interest, as Reed mentioned, we want to do sessions that you are most interested in. All right. So I have a model in production. I've built it as a data scientist. Now what? How do I let my end users use this model? This is where AI apps and Wave for building apps comes in. So I'm going to look at a running version of an app that I've built for this specific model. This is one of our demo applications, and it explains you and walks you through how it works. So we have a little bit of our custom data that we trained on, which we saw in Driverless. We can see some plots that might be interesting to our end users. For example, churn has historically been really bad in California and Texas in comparison to other states. And we can also see the distribution of churn by the total amount of money someone's paying. It is not too surprising to see that when you're paying way more than average, you are likely to leave to a competitor, but we can quickly get that insight. We're now going to go to the View Today's Caller section. And here we have data where we have information from new users. We are sending that information to the model endpoint that we just saw in MLOps, and it's sending back predictions. So here I can see this person has a medium likelihood of churn, and some of these are more lower. Now, my customer service representative might want to click on one of these rows, get more information, get the reason codes for why this person wants to churn. But here we can see our real-time predictions being used live. Now, this is where I want to talk about AI apps a little bit. Everything on this page was fully customized by the data scientist using Python to display the information that's interesting about this model to their end users. So someone in my call service center, they're not going to open up their terminal and put in a curl command, about the customer. That doesn't make sense, but they can look here, they can put in their customer's ID, and they can get the likelihood of churn automatically in a UI. So the way this UI is built is using H2O Wave. I can see the H2O Wave library here for anyone that's familiar with Python. And if I scroll down in the source code of this app just a little bit, I can see that there's a series of UI objects. So I want to have a separator that has the word overview. That's this right here, that separator with the word overview. I want to have a button that is labeled with about this app. Here's my interactive button. So the only thing I have to know is Python. I don't have to know HTML, JavaScript, CSS, or even backend programming, server-side programming. I just have to be able to use these components and build out the custom UI that I would like to build. So we have lots of other apps, and we can do a demo of Wave where we look at building an app together. But at this point, we're going to wrap up our demo for the day.